All right, ladies and gentlemen, here's example problem number one. We have a book at rest on a tabletop. Now we're going to diagram the forces acting on this book. Now to diagram the forces acting on this book, we're going to go up to the toolbar up top. Let me see if I can, yep. And we're going to click, oh, I'm covering up the drop-down menu. Let me get my video out of the way. So we're going to click Insert. We're going to go to Shape. We're going to choose a box because as I said in our notes, all objects are going to be represented by boxes. There's our object right there. That's our book resting on a tabletop. All right. Now, I told you guys in the notes there's one freebie force for every object that's on Earth. Now, that freebie force is the downward force of gravity. So to do that, or to draw that force, we're going to go to this drop down right here. You go to arrow, and you just click that. And when you, oh, I got to re-click it. All right, so once you click it, you can click in the middle of your box and draw a line. If you hold the shift button, it'll help you draw a straight line. So there we have our arrow, all right? Now to label it, I'm just gonna click the text box button right here and put a text box. I can label that capital F, lowercase g. And that right there is our force of gravity. Put it right next to that arrow. Now, our book also has one other force acting on it because we know this book is at rest, so it's not moving. Now, it doesn't say anything about it being pushed or pulled. We don't have any ropes attached to it. There's no springs or elastic bands, so there's nothing like that. But it is resting on a surface. So we are going to have a normal force opposing our force of gravity. Again, I'm just going to go up to the arrow again. I'm going to click on it, and then I'm going to go right to the middle of my box. And again, if you hold down the shift button, it helps keep your arrow straight. And I'm going to try to draw an arrow about exactly the same length as my force of gravity arrow, just about like that. So we can see that these two arrows are about the same length. And I'm going to, again, go ahead and put in my text box, and I'm going to label this as my normal force. So Fn. All right. Now, because this description doesn't give us any indication of any side-to-side forces, again, no pushes, no pulls, nothing like that. It's not moving, so there's no friction or air resistance. This is a completed force diagram right here. All right. We have our normal force acting upward on our book from the tabletop, and then we have the force of gravity from the earth pulling downward on the book. Now we're going to elaborate on this a little bit more in the next problem here. So our second practice problem. A rightward force is applied to a book in order to move it across a desk with a rightward acceleration. So this right here tells us that we do have some kind of unbalanced force acting on this object. So we have a net force now. Diagram the force acting on the book and consider frictional forces. If you see consider frictional forces, it means to include them in your diagram. If you see the words neglect or ignore, it means you can ignore that force for the purposes of your diagram. So again, we're going to go to shape. We're going to choose a box again because our book will be represented by a box. And then we're going to draw our forces. Because this book is still on a desktop, we know that we still have the force of gravity and normal force acting on it because it's on Earth and it's on that desktop. So I'm going to go ahead and start by including the two forces that we put into the previous diagram. Again, I'm going to draw those forces coming out of the box. There's my downward arrow. And there's my upward arrow. And then I'm going to label these forces. B, and then insert another text box for Fn. All right, so now we need to consider our side-to-side forces because we've got the two that we identified from the previous problem. Now we need to identify the two side-to-side forces we're missing here because we do have a rightward acceleration. A rightward force is applied. So guys, this gives us the name of the force and everything right here. We have a rightward force that is applied. That's an applied force. So we can draw an applied force to the right. Now, the thing I want you to keep in mind when we draw this force is that because we have this rightward acceleration, we know our rightward force is our largest force. So we're going to draw our right arrow a little bigger than our left arrow. So I'm going to make it, I'm just going to overemphasize it a little bit. And here we go. Now I'm going to go ahead and label this, like we just discussed, FA. All right. And now we need our leftward force because there is a leftward force. They tell us right here, consider frictional forces. We know frictional forces from our notes will oppose the direction of motion or be opposite to it. So we're going to go ahead and draw that in now. And again, I'm going to make sure that my rightward force is clearly my biggest force. I'm going to make my frictional force much smaller because we have this rightward acceleration. We need to be clear that our rightward force is the largest force. And then I label my frictional force FF. All right, so we have our force, our normal force from the desk. We have our force of gravity from the earth. We have the applied force on the book causing it to accelerate to the right. And we have our frictional force. Now, guys, for this problem here, if it were asking us for the net force, because there are no values, we could say our net force, or F net, is equal to the right. We can at least give the direction of that net force. Now, if we had values for each of these forces, we could subtract these values because they're in opposite directions to end up with our overall force or net force acting on the object. All right, ladies and gentlemen, this concludes our example problems in our notes for the day. I hope you have a